Hello, my name is Ulili. I am a senior cloud application architect here at AWS ProServe. Today I'll be presenting your infrastructure is code with AWS Cloud Development Kit, aka CDK. Let's see our agenda for today. So I will do a little bit of introduction, why infra is code, and what problems CDK is proposing to solve. For that, a bit of overview for CloudFormation, Terraforms, and the basics of CDK. And of course, a demo so we can see how we can use CDK to provision resource, to build Docker container, and also grant permissions. Let's jump in. When we talk about infra as code, think about infra as code just like you build your application. You have it coded, you version it on Git, and have it reviewed for your peer reviews, so that way you can automate with some CI/CD, validate, security scan, and so on. Exactly the same thing. Those practices, you can use them to build your infra in the manner that by coding it, it can be reviewed, it can be automated, it can be scaled to deploy repeatable and give you more peace of mind. That's pretty much what infra as code is about. If you want to use infra as code, these are like one of the core services and tools that out there that allow you to build your infra as code. You can use serverless if you want to deploy some stuff. You can use Terraform, you can use CloudFormation, and of course CDK and more. Let's jump on and see a little bit overview about CloudFormation. So it is good to go back in time and understand what was the problem in CloudFormation and what kind of problem CloudFormation solves, what are the opportunities out there. Think about this. At the very early days of cloud, we only had console and later on CLIs and SDKs. That was good. Customers start using it, they're loving it, but at some point it's like, well, how about if I need to redeploy these in 2 accounts, 3 accounts, multiple accounts, and all of a sudden the customers start growing their environment in multiple accounts. Now you need a repeatable way to deploy the same resource. It became like unthinkable if you have to click next, finish, as much that the console is good, but it's not repeatable and it's not scalable if you have to deploy that same thing multiple times. So this is where CloudFormation came to solve those kind of problems. And even back on the days when you have CLIs, well, you can go in CLI, you can create everything, but now folks start using like bash scripts and PowerShell to provision the resource. The problem we come up with, you ended up with some orphan resource when it came time to delete. Let's say you started your application, you have your VPC, you have your network load balancers or your application load balancer, you have your NAT gateway, your internet gateway, all those foundations, and then your requirements change. In middle of those 10 or dozens of resources you provision, it may be hard for you as a human being to know exactly which one to update first or which one to delete first. And even if you manage to delete some, because you don't know the dependency, you say, oh, let's try to delete this VPC, just error out in yourself because there are other resources depending on it that you cannot deploy. And that became hard to maintain, to take care. This is where CloudFormation came to bail us out, like save us. So take a look on this. From the right side, you have a CloudFormation template. This template is creating S3 bucket, which is great. This way we can repeat it, we can deploy it. But now, when we start developing more and more template, we figured out we still have some opportunity to grow. So CloudFormation solved the server side very well. It allows you to, deploy your resource, redeploy your resource, reuse your template, and so on. The problem we'll still have with CloudFormation development is the build side. Before you got your first template up and running, it may take you hours, days, even weeks before you complete your before you have your complete stack. One of the reasons is, well, it is YAML and JSON, and you have to learn the syntax. That learning curve can, have your entire team sit there for a week, 2 weeks, and more just to learn CloudFormation. When they master it and they start building, they realize, well, AWS has hundreds of services. Now you cannot memorize all the syntax. What ended up happening, we have our code in one screen, and you have the CloudFormation documentation in other screen, and you go back and forward. Oh, what's the syntax for this one? What are the property for this resource? And then sometimes you ended up copying from the CloudFormation documentation, bring it to your code, and change it, and so on. Even though the IDEs have some linking, some tooling, some plugins that can help you, it's still not like a real C# code where you have that full integration with your IDE. And another problem you may see when you're building CloudFormation, it can get really verbose. Like, it can have long line of code of text that you have to, write them. And if you get something wrong, you may be figuring out only by running linking or deploying it and failing doing yourself to realize that you're failing. That became, long loop, development loop, go back and forward, try and fail before you got one working. Another problem with CloudFormation workload is you as a human being, depending on how big is your resource, it became harder for you as a human being to understand the relationship between them, to know which one goes first, which one goes later. CloudFormation does that very well by scanning and build some kind of dependency graph. You know exactly which one to deploy first and so on. But you cannot easily see that but just by looking on your template, right? And organizing your code became harder. So you start here, put your VPC here, and then it's like, oh, I have my EC2, and then it's just hard because at the end of the day, this is a text file, this is a JSON file, it's a YAML file that can bring some challenge. But one of the really tough part of working with CloudFormation is this thing can get very long. So imagine this: I have 20 lines of code to create one bucket. How about if I need 10 buckets with the same property, maybe just changing the name? Today we can use something like macro to help us with that, repeatability. But what ended up happening most time, you ended up copy and paste that and just change some property. Because if you copy and pasting code, that itself make it longer. And if you think about one bucket, 20 line of code, if I have 20 resources, 10 resources on my template, we may be talking about, thousands of, couple of thousands of line of code, which is unthinkable for you to just read them and understand. It's just a long, unreadable file, and that can be hard to deal with. What else we have out there? So the industry move around, and we have this cool tool called Terraform, which is created by HashiCorp. They kind of improve in some of this opportunity that CloudFormation let out there. It creates some cool new things. Just like CloudFormation, you can create, update, and delete your resource. Terraform will handle that very well. It has resource variables, output, and so on. But one of the key main things that Terraform introduces is the concept of model. So Terraform allows you to build your infra as models that you can import and reuse that way. So let's imagine, remember that S3 bucket I was talking about? Now you don't have to, copy and paste it. You can just create it as a model, external model, or, even internal model, and then refer it into your project. That way you pass just a couple of parameters and you are rock and roll. But still have some opportunities out there. When it came to Cloud Terraform, just like CloudFormation, you have the learning curve. I mean, developers, builders, we are building C# code day and night, Java code, TypeScript code. When it came to the infra, you have to stop there, go and learn and learn. Even if you are from the platform side, you help build the infrastructure. Still, you have some time to catch, to learn, and before you start really deploying a production ready code. So that learning curve still can be a challenge. And again, it's still hard to see relationship of your resource just by looking into your code. Terraform also does a very good job to decide which one to build first, which one to build later. It even allow you to arbitrarily say, hey, this resource, I want this depending on the other one, and so on. But sometimes you end up putting some circular reference, but it will detect that and say, hey, you just build a circular reference and try to break it, right? And it is hard to implement advanced logic. So where this is coming from? Think about that model. Now you own the model for S3, but team A may say, hey, we need just this parameter and that parameter, and then you give them as a variable. But team B may need some set of variation of that. And if you need to do some advanced logic to decide what to put, what not to put, if this is passed, should I put this property or should I remove this property? You just cannot do those kind of advanced logic because it gives you some sort of if and else, which we call count, but it is still limited. You can say count if 1 provision this resource, if 0 do not provision, if 10 repeat this resource 10 times, and so on. You have some sort of loop for, but it's still limited. You cannot do really advanced logic like if and then and else, if else, and combination of parameters. That's just not gonna happen. It's not the way Terraform works, right? And another huge downside of Terraform is the unit test and integration test. So as a developer, we are used to all this mechanism, all these toolings that we have in place to check our code statically, to validate by using unit test, by using integration test. That's just not something you have when you're building your infra using Terraform. Even though the community start putting some toolings out there, building some abstraction on top of Terraform, still not like allow you to do a really good unit test and integration test. So think about all these opportunity, learning curve, that long loop, just like CloudFormation. If you are using Terraform, you have the same problem when it came to the documentation. So you have to open your Terraform code in one side and open HashiCorp page in the other side, go back and forth every single time, to see the correct syntax, the combination of parameters, which property should you put, and so on. That can be really painful. And you have other cool things like, for example, the data source that allow you to, in my case, if you look at this line 6 and 11, that allow you to do extra thing that you couldn't do with CloudFormation, like for example, zip my file and some function to concatenate some string and do some combinations, some logic there, and so on. You even have some functions to allow you to manipulate a list, and you have you can do some arrays validation, some map, and so on. That is cool, but you still have this huge limitation that just the downside of having the long development loop is just tough when it came to building Terraform. So let's evolve. What else we have out there? So this is where CloudFormation and Terraform was letting us down. And now we came with Cloud Development Kit, which is CDK. What is CDK about? So CDK, from the very insightful way, come up with this idea. Let's meet developer where they are. folks are already developing their application building one of this language. I will say 80% or more, I will shoot for application you have there are built using either TypeScript, JavaScript, Python, Java, C#, and Go. So folks are already familiar with this. If you are a builder, the probability that you know one of these language is huge. So instead of having you to learn a new language, new syntax, and new annotation, how about you just use your C# capability that you already know and start building your infra? That's exactly what CDK does. So it allows you to build your infra using any of this language, using your preferred programming language. And under the hood, use Node.js, the Node.js to, get whatever you classes you have in your language. It will get that binary compilation and use that. The engine of CDK will be this Node.js engine that will generate your CloudFormation template. At the end of the day, CDK is not what we deploy. What we will deploy will be a CloudFormation. So the problem that CDK is solving is that development loop of CloudFormation that was really long. Now we have a way to, work and, all those opportunities that CloudFormation led for us, it's been solved with CDK from the builder side. Now you don't have to deal with that long, infinite YAML file or JSON file. You can organize your classes. That's just like you organize your C# class. You can reuse your class easily. You can even import them as a library, and you can, focus, divide using the object-oriented model to, scope your methods, your classes in a way that they make sense. They become easy to read. And again, because it's C#, you can run unit tests. You can run, some integration tests to validate it and so on. This is really a huge advantage if you compare it with nothing and have to do that from that text file or the YAML file and JSON file and so on. That's one of the huge advantage of CDK. Use your preferred language and build your infra. And then what CloudFormation does very well is when I got my template, CloudFormation will take care of the business. CDK will generate that CloudFormation template for you, and you handle the deployment. So think about that CloudFormation that CDK generates just like your binary. You as C# developer, you don't focus on your binary. You don't even care about the binary. You build your code on VS Code or on Visual Studio. When you're done, compile it and ship the binary. Don't worry about that. Same thing. When you're building infra with CDK, you focus on your code. When you complete, CDK synth, CDK deploy, and that will handle the deployment. If you go to the console, you're not going to see like CDK servers. You will see CloudFormation. So that stack you'll find in CDK will become a CloudFormation stack. That's how pretty much the basics work. So it is designed from the ground up to make the creation of infra very simple and allow you to go deep specific to what you need. You still have all the capability that CloudFormation support. You have them supported in CDK, and with this plus, because now you have a total control on your classes and object, you can build abstraction on top of them. You can build, inheritance. You can build all the logic that makes sense for your business or for the reusability of your models, your components. This helps you a lot, and you don't have to worry about, spending your time trying to read that long file. And as I was mentioned, just like the CloudFormation stack, you will have the reference that represent your stack in CDK. And when you deploy that, that stack became a CloudFormation stack. This allows you to, integrate, and you have all the flexibility, capability that the programming language support. You can use your favorite IDE to build. You don't have to go out with your IDE and so on. This is how CDK pretty much uses it, and you can use it to construct any resource like Dynamo, S3, anything you think about that you can do today with CloudFormation. you can do it in CDK. And the app in CDK will be constructed by it is equivalent for what we call stack in CloudFormation, and you have multiple constructs. Construct is the concept of, small part of the code logic that does a group of things. So we have this concept of construct that CDK introduced. Think about this. There's 3 levels. The first level is a map, a direct map 101 between CDK and CloudFormation. So everything that CloudFormation support out there, if you go to the CDK, you'll be see it like there's a naming convention. It will start with CFN. That means it is a level 1. That's a direct 101 map with CloudFormation capability and properties and so on. You may not want to spend your time there unless you don't have a level 2 or level 3 for what you're looking for. Your sweet spot will be between the level 2 and 3, because your level 2 is one or more of these level 1 together. Excuse me, where your level 2 is one or more L1 combined to build you something more directed for what you need. Think about this. If you have to create a Lambda, what do you need to do in CloudFormation? You need to declare your IAM role. You need to declare your CloudWatch logs, and then the Lambda itself, and then you go back there, get your code, zip that folder, upload it to S3, get the URL, and put that URL in your CloudFormation. That's a long thing. When you're working with L2 in CDK, you have a class that represents the function, the Lambda function. So you'll say a new function or new Lambda function, whatever the name of the class, that will abstract you away for all those underlying things that is required in order for having the Lambda. And it will give you only a properties that you can set the property. I want this and want that, and that will build it for you. If you do not pass any of the optional property, it will give you security and best practice built in, which means the best practice, the recommendation properties. If you want to change and tweak things, you can just change the properties and move on. This is very good because that L2 can do things like, oh, just give me the folder where is your Lambda. It will take care of all the zip part, the upload to S3, and put that reference into your CloudFormation template, which is the output. This is really good. It helps you a lot. And sometimes you even don't know what's the best practice. By putting only the required parameters and letting the optional parameters go with the best practice, that helps you a lot, especially when it came to least amount of privilege. You may not know exactly what will be the best recommendation for least amount of privilege. Let's think about L3, patterns. So now you have the L2, which is components, individualize it. But how about if the business requirement asks you this? Can you build me a Docker application, web application, or web API behind an application load balancer that runs on ECS with Fargate? This is a well-known pattern. You're not going to be the first one, either the only one or the last one doing that. A lot of companies have been doing this out there, and we have a lot of white paper recommendation how to do that. But more than white paper and telling you how to do that is the giving you a class that can actually do all these things. When you're talking about patterns, let's say I want a networking load balancer front loading my application on ECS sitting on EC2. Boom, you have it. You use one class that you can just pass, hey, this is my Docker image and this is my cluster or couple of other parameters, and that class will take care of all the underlying things that you need to do. So now you have a more focus on specific business use case, which is a huge advantage. You can have the reusability, and the best part, that will build your resource with the least amount of privilege, with the security blast. This level 2 and level 3, they went to a scrutiny review long process before they get GA. When they get GA, that means something you can rely on, you can use them, and take advantage of this huge of contribution brain of that people put out there to build this pattern, and you use them to in your benefits to accelerate the process. If you have to do that in CloudFormation or Terraform, that's probably going to take you hours or days before you come up with the correct set of property and toolings you need to do. All right. Now that we know about CDK, all this L2 to L3 and how they work, let's see a demo. The best part of the workshops and the session is to see a code and see it working. So for this demo, imagine this architecture where I have web API that receive the load from a customer and from your users, and then it pastes it into SNS. From that SNS topic, there will be multiple other microservices that can, subscribe the SNS. In this case, I have two. The group 1 will have its own SQS that subscribes, and I have a worker, .NET worker service that will be reading this queue, and once the new message came in, it will process the new message, put some business logic there, and save the results on Dynamo table. From the other side, imagine a worker service that will go maybe prepare things for your big data analysis or for your search, and then store that, or even as a login mechanism, and store that in S3. Now you have those two worker service working there in their own way, reading the same SQS, and I have X-Ray and CloudWatch to help visualize this. All this is running on top of ECS on Fargate, and of course you have your Dockers on ECR. Let's see how we can build this. So I will give you a second or minutes to see this link. Go to this GitHub sample repository. You have this the code that I will be working on here. So let's switch to the code. Here's the code. Here's that repo. So this is the repo I was mentioning, which is microservice.net AWS CDK. So in here, I have my web API. I have my resource, where my source folder, where I have the application and the infra. So if I take a quick look in the application, this is a web API. I have my Docker file. This Docker file is .NET 6 web API default 1 standard, nothing more there. But when we need to focus here is the infra side. So this is a CDK project. If I come here, I have my infra stack. So in my infra stack, let's see what we have. As I was mentioning, everything is a stack. This is the base construct where we inherited my application star, and this is where my deployment will start. So if I go to the program, my program will instance this. This is my infra stack. This is the name of my stack, and my deployment begin from here. So my infra stack will inherit it from the base stack. From the base stack, I have my deployment. So in here, I start with the VPC. If you take a look on this, I have 3 or 4 lines of code to define my VPC. man, this is a mind-blowing. But goes beyond only VPC. This bring me every single thing that a like workable VPC need, from NAT gateway, internet gateway, AZs. In this case, I want maximum of 3 AZs. So this will go there, give me provision the AZs that I want, and so on. In here, another huge benefit is this. So remember, when you working with Terraform or CloudFormation, you need to switch the context every time back and forward to be able to see the documentation. Using CDK, you have that documentation built in. You just stop by and point it here, and you can see the documentation. You can read it. You can understand what is this properties about, and you have the auto completion in here that will help you put any properties that you need or that you may need to build your application. That's one of the cool advantage of working with CDK. This is a real C# code that you are using to provision your resource, right? As you can see, I import all these libraries and I start working from there. In here, next step is, so in my case, I wanted to specify my VPC with this CIDR block. And doing that, now I need my cluster. And this cluster is my ECS cluster because I need the container inside, which is by default is false. I have to create my cluster. But honestly, if I didn't need this, if I like, okay, give me whatever the VPC, I can just jump directly and build my level 3 with gonna deploy me everything I need, including the VPC and the cluster. So this VPC and this cluster, I'm using them here. This is my level 3. I want an application load balancer with Fargate service. So look how pretty is this. I have one class that abstracts me every single thing I need. And now I focus only on the required parameter. In this case, I want to pass this my cluster, and I use benefits on this. This is a C# object, right? I have it here, I declare it, set the property. Now I can reuse that object anywhere in my code easily. Different than CloudFormation and Terraform, where I need to copy and paste, and so on. Now I refer here, and here is just defining what, like, the size of the memory I need. And again, you have all the documentation guiding you through what is the 1024 mean. That would mean like, okay, you have a gig of memory. If I put 0.5, that would mean like I have like 512 and so on. It explain you right in your face the whole documentation what it mean. That way, again, you don't have to switch to context. And the focus of my container is actually in here. So in here, I have my task definition where I have my image, my container name, I enable log, and I have the variable environment. Another cool thing is this. So take a look on this. I'm saying, hey, my image, grab the image from Docker assets. Where is this asset coming from? So if I go back to my code, this is where I am declaring my asset. This is where I am building my asset. What that does mean. So in order to build a Docker workload, you need to do things like Docker login, and now you have the Docker, either Docker Compose to build it or Docker build, and then you have Docker tag to create the tag, and now you need to do the Docker push to send that to your ECR. If you don't have ECR yet in that account, you need to create one and grab the credential, and then you'll be able to push it. When you're working with CDK, you have this construct that is Docker image asset. What this one does is it allows you to build and abstract you away of all that heavy lifting of building Docker container. So you just point this to a folder, say, hey, this is a folder where my application is which is this folder here. And in that folder, I am expecting to use this Docker file. Boom, that's it. You don't need anything more. And then during the build time, CDK will know how to use the Docker engine to build your Docker, push it to ECR. If you don't have ECR, it will create one ECR repository for you, and it will push your image to them. That is a huge benefit. Now I can just use this asset and refer it. When I use this container image from Docker asset, this one will extract the URL, which is my image URL and my image tag specifically for this one, this each build, and then put it in my definition, my task definition. This is how cool it is to work. So CDK go beyond only deploying your resource, but your cloud resource, but it actually can build your code. It actually can build your Docker image and push it out there. So next thing is, let's think about the design. Again, remember, I have one web API that posts the SNS topic. So this is my SNS topic. It took me like 5 lines of code to declare my SNS topic. And I was like, okay, this is my message and this is the topic. And honestly, if I didn't want this, I could easily create this topic only by doing something like this. This is a valid topic. Like literally 1 line of code, I create that. If by doing this, it will say, okay, you don't have pass any property. It will generate a name for me. It will generate the default recommendation for me, and so on. I could have easily done something like this, but I wanted my topic to have a name that I can easily identify it. So that way I put this topic name and I have my display name. Now, let's say the other workloads will need to use this topic. For that, I need to export it. And my own Docker image from ECR is not aware. It doesn't know how to publish to the topic. So to be able to publish, I need to grant publish permission. This is in my agenda, I was talking about the grant permission. This is it. This is how I grant the permission. So by using that C# object that I create a topic from, I can use a method that say grant publish. I can use other method. If you see, I can add subscription. I can add, and right on, I have all the properties and methods that this topic support. This allows me to build my code faster and naturally, just like I build my application on C#, I have it in here. And this is how I add the permissions. And then for the workloads that are outside of this, remember I have 3 projects. I have the web API, the worker service for DB, the worker service for integration. And now for those other 2, I am just gonna use a level 1. Remember I was mentioning the prefix with CFN. This is a level 1 construct. And I'm using this level 1 to send the output of my ARN topic. So I will export this using this name, the demo SNS topic, and this will export the ARN of my topic. That will allow me, if I go to the other project, you can see how I can import this from that other project and reuse it from there. So if I get to the project for the web, the service worker DB, I can go to my infra, and in here you will see this is how I can import existing resource created from other project. And we know that divide and conquer, when like you're building your workload, it doesn't have to have all your resource in one thing. Let's take an example of, the VPC ID, or even in this case, the SNS topic. You need to subscribe an SNS topic that you are not the owner of that topic. Somebody created and you just need to refer it. In that case, just let them know, like, okay, can you export the ARN so I can come here and use CDK FN to import the value. From that value, I will have my construct that can allows me to import a topic. So I will import this object, which is create me a topic object from an array. By passing this will create a logical reference that allow me to now use this object, just like if this topic were defined inside my project. And I will use this object to do things like, grant the permissions to subscribe this topic. Again, remember the design architecture proposal. I have two SNS that need to subscribe the topics. This is where that subscription is happening. So in here, I have the SQS for this workload that needed to subscribe this SNS. So I have this SQS defined here, give it the name, and now I came here and say, hey, create a subscription for SQS. This will handle all that SNS policy to add, to allow the subscription, to allow this specific SQS to subscribe my SNS, and so on. And if this workload is the one that need a DynamoDB, this is how I declare a DynamoDB, and I will set the parameter for my DynamoDB so the way I can give my application permission to publish and grant rights into my Dynamo. That's it. Another cool thing that I would like to highlight here is the code reusability. So think about this. All these three projects need to have, I am building using distributed tracing using X-Ray. So they need to have an X-Ray demo running beside my container. I don't have to build and repeat that code, copy and paste in all these three projects. What I can do, because this is a real C# project, I can extend this method. I can extend this using the cool feature that C# has, which is the extension library. So if I go to here, this is where I create my extension in my common project. So I create this extension. This is the C# syntax to create extension. I am extending this class, this task definition, and object to add a method called add X-ray daemon and pass some property. And in here, I have my daemon where I can define the small size of that daemon that are going to be a sidecar. And this different than my code. I am not building this image. So in here, I am actually pointing to a public ECR repository where I have this X-ray daemon that I can put by my side of my container. And by doing that, I can reuse this on my task definition just to use that extension. Same thing, I'll use that. I'm using it in here on this project. All the three projects, if I go to the integration one, you will see at the very bottom, I'm using that extension. This allows me to use C# capability, just like, I build my extension for my application, I can build them here and so on. So let's deploy this and see how this can work out. To deploy it, pretty much we can do CDK deploy. That will provision everything that I declare here. So how that does work? If you want to know, let's go for example in this project. There is a way that you can before you deploy it, you can synthesize your project. Say generate a template for me. So if you run CDK synth, this will synthesize the project for you that generate CDK synth. There you go, typo. So when running the CDK synth, this will compile the C# project, use the Node.js engine, and generate what I need, which is the end template, just like your binary. That template is the one that will get deployed. So that's it. Another cool thing, let me just export all this output into my YAML. And this will give you a notion, if you had to build this, how big, how huge this could be. Beside even the Docker, remember the Docker, you have to do all those things, But right now, I'm just taking a look at, I will take a look only on the CloudFormation that will be generated. You will see how big that will be. So I have 700, almost 800 line of code here that is generated from roughly 125 line of code with all this comment in it. So this 100 of line of code became 700 line of code. This is where that difference came from, when it's like, hey, YAML and JSON, they are huge. They can be like really long. By using CDK, more comprehensive is C#. It's what you are familiar with, and it's allow you to create that. So let's go ahead and deploy this project. So just for the demo purpose and be able to deploy it fast, I create shell scripts, a PowerShell script that allow you to do all this comment. Go there, you can read them to understand, to learn, and see how this can help you. You can reuse this, twist this for your own benefits. So I'll go ahead here and deploy this, and we can see it working. Clear CDK, actually not CDK, but I'm gonna go direct to the deployment, and this will go compile the Docker project, build my C# application using Docker, generate my Docker image, tag my Docker image, publish my Docker image. So that's going on. It will do that for all the three projects, and my script is gonna show you an output, which is the URL that I can just use and paste and test this. So my deployment is going on right now. This is building my first project. Another cool things about this tool is, like, because what you deploy is actually a CloudFormation, if I go to my console, I'll be able to see the progress there. So I have this deployed. The first project just showed me these outputs that I was mentioning. This is where my output has been shown. So if I take a look here, I have my ARN, and this is my topic ARN that I was mentioned that I exported, and this is the name I used to export, and my VPC ID that I am exporting, and this is the endpoint that I can use for test to test my application. So I'll wait for the other to build and deploy. So this second one is deploying right now. The deployment's still going on, and once it's complete, I will go to the third one. It is about to get to the third one. Then we can see test the entire result together. Let's give it a couple of minutes to complete. I previously I already deployed this, so my deployment went faster. This could take you around 2 to 5 minutes depending on the amount of resources you have on your project to deploy. But because I really deployed this for the sake of time, it is going faster, so we should be able to demo it. Now it is completed, and it generates me this URL, so I can use this URL in Postman or in Thunder Client. In this case, I'm using Thunder Client integrated with my VS Code. I don't have to leave my VS Code to do to test my APIs, and I will come here and test it. As you can see, I have a 300 results, and it generated me a traced ID. So let's go here and put another information, and demo.net, and submit the request, and I have 200 again, and this is the trace ID. So 30, and submit another request, I have this. So let's go back to my console, and I will see how this result would look like. So from my console, I can show you guys the deployment, and I can check the X-ray, and we go from there. Let me pause here, and I will open my console. Here's my console. So if I come to my console, I can go to the CloudWatch, and from CloudWatch, I can go to X-ray traces, and I just copy one of the trace ID that I got there. I can come here, and I'll be able to see. Okay, let me switch to correct region. This is the correct region. I will be able to see my trace. Let me go. There you go. So these are all the requests that I've made. If I came here, this is what the trace I just copied. I can open it, and I will be able to see all the resource, all the calls in my my trace. All the logs are here. I can see the sitemap. Sitemap will show me the workers and so on. So that was it. Thank you so much. Here's some resource that you can use. Go to the CDK workshop, play around with it, enjoy your time with CDK. I'm pretty sure when you start working with CDK, you may not look back to CloudFormation workloads or Terraform and so on. Thank you so much. My name is Ulili Nyaga, and it was a pleasure presenting you CDK. Thanks. Engage me in LinkedIn. My LinkedIn will be /in and ULILI5. That will be me, or you can email me at uli@amazon.com. Thank you so much. I appreciate you spending this time and enjoying the event with us.